Hello, and welcome to my presentation. My name is Noga Meiri Luin from the MS Corporation. I'm going to share with you an experience that we had upgrading our report system. So again, welcome to my presentation. So the title of the presentation is Learning from Experience Requires a Collaborative Team Effort. It is an integrated software solution for automated and reliable distributed report system. Please email us. Here we are, the collaborators on the paper. So we'll start with the background. Our reporting team has developed and used a web report system for the last 10 years, which did the following. Different programmers contribute their reports for platforms and studies. All reports upload to one website. Common setup programs standardize the programming process and relieve programmers from repeating common code. One report program includes all reports for all platforms and studies and runs nightly. A summary Java program follows. It uploads the reports to the web upon success. Upon an error, a designated programmer investigates the error is corrected, and the whole program reruns. Background. Over the 10 years, the requirements evolved. While we started with a small number of similar studies, okay, I'm sorry, I'm going to repeat this slide. So just to give you some background on our reporting system. Over the 10 years, the requirements evolved. While we started with a small number of similar studies, the number of concurrent studies tripled. The studies were very different from one another, and substantial customization was needed to meet the needs of each investigative team. As the system grew, the advantages of using one program to run everything were outweighed by the growing size. Running time was too long. Debugging of one long, complicated program became harder and took time. Since they were all part of one program, an error in one study prevented all other studies from being updated. So we had an opportunity to upgrade the reporting system, and our goal was that with the addition of new EDC platforms, our challenge was to create a multi-user, multi-platform study, SaaS reporting system that adheres to the following sometimes contradictory requirements. It should be reliable, standardized, flexible, and programmatically and computationally efficient. So you can see here that, for example, standardized and flexible, there is a tension between those two requirements. So here is the solution we came up with. Studies and programs are programmed and run independently and on different PCs so that failure in one does not affect others. In the same time, use common patterns, templates, and macros to achieve standardization and save programming time. Each step only executes if the previous one succeeded. For each study, 3 types of programs run in sequence, but independently in a batch file. The first one is an initialization program. It runs first and sets up the environment to save running time and programming resources. It verifies that the data has been updated. It initializes and creates permanent format catalog and datasets from the CRFs and additional project requirements to be available to all report programs. It sets these libraries to read only. The second type of programs are the report programs. They run after the initialization program and use the environment that it set. and it creates a separate log file and only runs on updated data and successful initialization. Last runs a summary program and does the following. It tests the success and completion of the reports. It collates the PDF reports to 2 different PDF consolidated reports according to specified orders. It uploads the individual reports and the consolidated reports to the website. In the end, it sends a status email, whether it was success or failure, and if it was a failure, it sends failure information. Upon failure, a programmer follows up by checking the log of the failed report, fixes the program and runs it, and reruns the summary program. Now, a batch creating Excel sheet is the central driver for the process. Programmers submit the programs by filling in 3 types of columns in the Excel sheet. The first type are columns that create the bat file. It has programmer name and path, SAS executable path, batch file name and path, and whether to include the program in the batch file, whether to run it. So here you see the columns we just discussed, each one in the Excel sheet. The name of the batch file with path, the name of the SAS programmer with path, whether to include or exclude, the order of inclusion, and then the SAS configuration path. A second type of the columns are input to the summary program. This would be the output of the program, which outputs are required, which are added to the consolidated reports, and order of the reports in the consolidated reports. And here they are in the Excel sheet. Output, the second and the third columns are the order in the consolidated reports, whether to check the output when the protocol is open or whether to check it when the protocol is closed. And then there are the columns that serve only for tracking purposes. The programmer name, which PC the program runs on, the scheduled time, and comments. So here they are, user's PC and time, and programmer. So when you click on the submit button of the Excel sheet, a generated batch file is created. So here you see snippets of it. So the first thing that runs is the initialization program. Here it is. And it first deletes the initialization file, and then it runs this program. The second sequence of reports programs would be the reports. So you can see here each program, like here is randomization, and then how it runs, and then the title page, and then it runs. So here are the second type of programs that run. And in the last, it's the web upload and the summary program that runs. Here you can see how in the batch file, it uses information from the Excel sheet. So these reports are distributed heavily. You have them running on different PCs independently of different protocols, but we need in our project to have something that ties them all together. So there are emails that are sent every morning. First one is the for each platform, for each protocol, a specific email, and it tells you whether the specific protocol was a success and whether how many files were found and how many files were expected to be found. This is a daily overall status email. It is an overall monitoring program that scans all the daily processes on our project. So it is by platform, and you see here the data update, the programs that run on top of the data update, and then by protocol, the different programs that ran for each protocol. So these are just different programs, and then you have the reporting system and whether it was successful or not. So a very important component of this project is relying on teamwork. It required collaboration among different players with different skill sets, namely data managers, statisticians, and SAS programmers with different levels of experience, and a Visual Basic programmer. The new system also, in the new system, we also incorporated many methods that are used in our company, not necessarily in our project. And we are exposed to their methods and their experiences through a monthly SAS user group meeting, where each one in the company share their experiences. We improved performance substantially. After implementing the processes described here, it takes 4 hours to add a new study to the system, and in the old system, it took days. It takes a full report set 5 to 10 minutes to run and upload to the web. In the old reporting system, this took 1.5 hours to run and upload a full set of reports. So thank you very much, and we would love to hear questions or comments. And thanks again for attending the presentation.